So we're going to start our final unit in this course with Chapter 7. And Chapter 7, we're going to look into doing some inferential statistics where we work with a sample and do measurements on that sample so that we can make some kind of inference about a population. So the first section is titled Learning about the World through Surveys. So we're going to talk about surveys and what makes a good survey and characteristics of a good survey. So the learning objectives for this entire chapter, Chapter 7, we're looking at survey quality, to identify possible sources of bias in a survey, and we're going to use something called the central limit theorem. Central limit theorem for sample proportions to construct something called a confidence interval. So in this section, our objectives: distinguishing between populations and samples and parameters and statistics, identifying possible sources of bias, and identify the features of a simple random sample. So first of all, populations and parameters. Now we've talked about populations before. I know we've used that term in this class. And so remember that a population, we can think of that as the entire, an entire group. Let's spell that right. Entire group that we're interested in studying or surveying. So a group that we want to find information about. The entire group is the population. A parameter is a numerical measurement that describes the population. And it can be some aspect of the population. It could be a mean on the population. It could be the size of the population. It could be a proportion of the population. But any measurement on the population that we may describe is called a parameter. It's really easy to remember that these go together because they both start with a P. So either population is the entire group that you're interested in. The parameter is something that we measure about that group, some sort of measurement. So a quick example here: data is gathered on the weights of all NFL football players. The mean of the data is then calculated. So all NFL football players represents our population. And then the mean weight that we compute, since we use the entire NFL, all of the football players or our entire population, that mean weight that we compute is an example of a parameter. So the parameter, remember, is a measurement on the population. A census, and you've probably heard a lot about a census recently because we're in the middle of doing one this year, but a census is a survey which measures every member of a population. The U.S. government attempts to get measurements on or data about every single person in the United States, and so that's why they call it a census. Most of the time, if we're working with data, populations are too large to do this. Generally, we can't go ask everybody in our population, say, the opinion of an issue. So instead, what we do is we pull samples. So most of the time when we work with this data in this chapter, we're going to be working with a sample and making some kind of generalization to a population. That's generally what our goal is. So we can think of a sample as a collection of, actually, I'm not crazy about the word collection. I prefer the word subset. So it's a subset of the population that we're interested in studying. So if we pull a sample, say if my population is everybody at Flagler College, all the students at Flagler College, then my sample would be maybe 50 random students that I survey. So it's some sort of a subset of the population. Generally, you want your sample to be representative of the population. That's a really important skill, and usually in research we try to do that. So then a statistic is a measurement, a numerical measurement on the sample. Again, sorry I didn't leave you a lot of room to write here. On the sample. So statistic is some sort of measurement that's on that sample. It can be the mean of my sample. It can be a proportion of my sample. It can be the size of my sample. But some sort of numerical measurement on the sample we call a statistic. How can you remember this? They both start with an S. So a statistic is always used to describe the sample. That's what you want to remember. Statistic is used to estimate the value of a population. So it describes the sample. The statistic is made on the sample or from the sample. Oftentimes we use it to make an estimate, however, about the population. Since we can't usually go out and ask everybody in the population, say, who they're going to vote for, we pull a sample and we make an estimate based on our sample. So sometimes statistics are called estimators because we use them to estimate what we think is true in the population. So a quick example here. A researcher is interested in studying the heights of Canadian women. She takes a random sample of 1,000 Canadian women and finds that the mean height of the sample is 64.2 inches. So the 1,000 Canadian women that she pulled, that is the sample. So she sampled 1,000 Canadian women. The mean that she calculated for her sample of 64.2 inches, what would that be called? That would be called the statistic. Since it's a measurement that was taken from the sample, it's a statistic. The researcher may then use this to estimate that the average Canadian woman is 64.2 inches tall. We can't possibly measure every woman in Canada for their height, so we pull this sample and we make some estimates based on that. Statistical inference, I've used this term a couple times already, but statistical inference is the art and science of drawing conclusions about a population based on looking at our sample. It always involves some kind of uncertainty because we can never work with the entire population. So there's always going to be some level of uncertainty. An important component of the statistical inference just in general is being able to measure the uncertainty. So how sure are we about what we're working with? How sure are we about our sample? Being able to give a measurement of that uncertainty is really important. Okay, so a quick example here. The chemical glyphosate is a common chemical used in lawn fertilizer. In January of 2017, a research center published a report stating that 42% of Americans believe that glyphosate is safe to use as a weed killer on lawns. This was based on a survey of 2,400 American adults. Identify the population. So who is it that we're interested in forming an opinion about or gauging the opinions of? And so in this case, they stated that 42% of Americans believed that it was safe. So our population is Americans, and if we want to be a little more specific, we can say American adults, because the sample only surveyed adults. We didn't ask kids or anything like that. So our population would be all American adults. Let me add that word, all American adults. So then our sample would be the 2,400 that we surveyed. So the 2,400 surveyed American adults. Since we can't possibly ask every American adult their opinion on this, we pull a sample of 2,400. The parameter of interest then would have been the proportion. So proportion is a percentage. Keep that in mind. So the proportion of adults, or well, let's say of American adults who think what? What are we interested in? What was the question? We want to know if they think this was safe. So the proportion of American adults who think or believe whatever this chemical was, glyphosate, is safe to use on their lawns. So they're interested in gaining an opinion of what people think. And so what proportion or what percentage, you're going to hear that word a lot, so get used to it. The percentage or proportion of American adults who think glyphosate is safe. We don't actually know what the parameter is, so we estimate it using the statistic. So the statistic is the 42%. The statistic is the 42% of the sample who said it was safe. We think that 42% of the population thinks this chemical is safe. We don't know for sure though, so we're estimating it using the sample. All right, so a little bit more information about statistics and parameters. So statistics are always knowable or known. So statistics are always known or knowable. The reason is because they're based on the sample that we collected. So if we collect a sample and calculate, say, the proportion of people who think that chemical is safe, we know what it is. We know it's 42%. So statistics are always known. That's not something we're estimating. We know what statistics are. However, parameters are typically unknown. We don't generally know what the parameter is. We don't generally know what the proportion of Americans who think this chemical is safe. We have to estimate it using statistics. In an election, we take polling data and we calculate a statistic based on our sample in a poll of how many or what proportion of voters we think are going to vote for a certain candidate. We don't know what it's going to be for the entire population. Now, of course, after the election's over, we have the data then. But ahead of time when we're making predictions, we don't know. That's another parameter that's unknown, of course, until after the election. So let's talk about some notations that we're going to see in this unit. So be familiar with these notations. Statistics, which are based, remember, on our sample. The sample mean, we've actually used this before. It's X with a bar over it. So remember, X bar. The analogous population mean, which we typically don't know, we use Greek letters for that, and that would be mu. So the Greek letter mu. We use this a little bit in section 6.2 when we talked about the normal distribution. We said the mean for a normal distribution. A lot of times we would use that notation. We'd say the mean for a normal distribution. We'd use mu for the symbol. So that's generally the mean for a population. The sample standard deviation, so way back in chapter 3 when we talked about X bar representing the sample mean, we also talked about a lowercase s to represent the sample standard deviation. For the population standard deviation, again, we use Greek letters for that, so that's going to be sigma. So let me try to write that a little bit neater. So sigma, and it's a lowercase sigma, it looks like an O with a little line coming out. That represents our population standard deviation. Again, you saw that in section 6.2. I think I used that a little bit when we talked about normal distribution. We'd say the standard deviation and we'd use sigma for it. Variance, we don't use a whole lot, but the variance is the square of the standard deviation, so that would be S squared. If you're talking about a sample, for a population, it would be sigma squared. And then proportion, this is the one we're going to use quite a bit in the next couple of chapters. A sample proportion is P with a little hat over it, so it looks like a little caret key. P hat is the way we would read that. For a population proportion, which is generally unknown, that parameter for population proportion would just be a P. So P represents the population proportion, P hat represents the sample proportion. So let's take a look at this example. Suppose the mean GPA of all 2,500 students at Flagler College is 3.03. And I made this up. I have no idea what the mean GPA is. So we're going to pretend it's 3.03. A sample of 75 GPAs from this school has a mean of 2.97. So first of all, who is the population? So that would be all Flagler students. So we're interested in looking at all Flagler students. So that's our population. Who is the sample? So the sample are the 75 that we selected to look at. What value is the parameter and what symbol do we use to represent this value? So the parameter would be the information on the population that the measurement on the population. In this case, we do know what it is. It's 3.03. Remember, it was a mean, so we're going to use mu to represent that. So mu equals 3.03 because it's a population mean. And this is kind of an unusual example in that we actually do know what the parameter is because I have information about all Flagler students, hypothetically. I could go to the registrar and get everybody's GPA and compute the mean. That's not going to always be the case though, so this one's a little bit different. What is the statistic? So the statistic is the sample measurement. So it was 75 students, but the mean that we computed was 2.97. So we're going to use lowercase, that's standard deviation. We're going to use lowercase x bar because it was a mean of 2.97. Okay? So bias, we're going to hear that term come up once in a while in this next unit. Bias, it happens when a survey method is biased. We say it's biased if it has a tendency to produce an untrue value. There's a lot of different reasons a survey can be biased, and if you ever take a higher level course in research methods, you'll talk about lots of different types of bias that could come up in a survey that researchers have to consider. But there's really just two we're going to talk about in this unit. One is called a measurement bias. The other is called a sampling bias. The third one we're not going to use quite as often. Using an estimator that is biased, that could be another source of bias. But the first two are the ones that I really want you to focus on and pay attention to. So let's talk about each of those individually. So measurement bias occurs when results from asking questions that do not produce a true answer or an accurate answer. Okay, so if the question itself causes answers to be untrue or causes people to say something that they maybe otherwise wouldn't say, that's when we consider that a measurement bias, because it increases the measurements of, say, the number of people who agree with a statement or something along those lines. It occurs when the measurements tend to record values that are larger or sometimes smaller than the true value. Measurement bias can occur in a variety of situations, including self-reported data. That's always an issue. Self-reported data. Okay? What I mean by self-reported, when you ask somebody to answer a question and you rely on them to give you an honest answer, and maybe they're not honest about it, that's self-reported data. A lot of times they are honest, but sometimes they're not. Think about, weight is a good question. If you ask people their weight, that's kind of a sensitive topic. So people may not always be honest about their weight. And so they may tell you a number that's lower or maybe higher, depending on their situation. And so that would be considered self-reported data and would produce a measurement bias. Another type of situation would be if the questions are a problem. So maybe when the questions, we can say, let's say leading survey questions. So leading survey questions. So if the questions themselves cause somebody to say an answer that's not accurate, or the question is misleading, maybe you ask a question in a way that is misleading, that leads people to say a particular answer that they might not say if they understood the question better. That could also cause a measurement bias. Another type, and this kind of related to the question, instead of leading questions, we could say non-neutral questions. And, as you go through, you hear the media talk about the election. We've got an election coming up really, really soon. That's going to be a big deal for our country. A lot of times you'll hear people talk about issues and things like that are going to be on a ballot, say, for example. And one thing you want you to think about is how could that survey have been worded that might have led people to say a certain answer, where the survey questions may be not asked in a neutral way. And this is really, like I said, this is an important issue. I want you to really think about it. A couple of examples here. So a high school wants to measure how often students swear. So the administration asks teachers to keep track of how often they hear students swear in the hallways between class changes. Why might this produce a measurement bias? And there's a lot of answers here you could give that I think would be plausible answers. A couple of reasons. Just a couple things I thought of. So students may not swear if a teacher is nearby, maybe. So maybe because teacher is nearby. Students might tone down their language. I'm sure there's other things you can think of. So students maybe aren't being as honest, right? They might talk differently when they're around their friends versus when they're near a teacher. You probably do that yourself. When you talk to your professors, you use a different language than you might when you're hanging out with your friends. And that's not unusual. So think about how a survey is set up. What might cause a problem, and think about ways that might improve the way the survey is set up. This is probably not a good way to measure this problem, and it doesn't seem to me like it's a big problem. But if it was something we wanted to tackle, this is probably not the best way to measure it. And so it would cause a measurement bias that would maybe push the swear words down rather than what they normally would be. So let's talk about another example, or another type of bias, which is a sampling bias. So a sampling bias occurs when the sample that you use to measure your population, when that sample is not representative of the population. And this happens a lot when people survey, even when you think about polling data, like for elections. If we ask people who they're going to vote for in maybe just St. Johns County, that probably doesn't give us an indication about the entire state. So that's not representative of the whole state. It might give us information about the county, but it doesn't represent the entire state. So we might call that a sampling bias in that case if someone claimed that it represented the whole state. Internet polls are very common with local news organizations. Why might an internet poll produce a sampling bias? It could be maybe that people volunteered to respond. So voluntary response could be an issue. So the people who were really interested in the issue are the ones who responded. If it's online, we might be missing people who don't follow that news organization. So only those who follow the news station will respond. If you think about, I'm not trying to be, I don't want to be too political, but if you think of examples of news stations where only certain people might watch that news station, and they do a survey where they ask their viewers a question maybe on their website, that's probably going to give a sampling bias in terms of it's not representative of the entire population, because anybody who doesn't watch that news station will not respond because they just don't follow that news station. So that's creating what's called a sampling bias. I've got some more examples here that we're going to look at that I think will help solidify these ideas. Important questions to ask: what percentage of the people who were asked to participate actually did so? So if you've got, that's another type of bias, as if it's a low percentage, that can create another kind of bias. Did the researchers choose people to participate in the survey, or do people voluntarily decide to be in the survey? If a large percentage of those chosen to participate refuse to do so, that's often suspicious. So a couple of other examples. Identify possible biases in the following situations, and there may be more than one answer here. A survey of college students' music preferences asks, do you like Dave Matthews Band or another band? So this is kind of a silly question, but the idea here is if you saw this on a survey, this would kind of maybe raise an eyebrow. Why would I ask you this? Why would the question be phrased this way? Probably because I'm trying to get you to say Dave Matthews Band, right? You might not have thought of Dave Matthews Band if I didn't bring it up in the question. So this would produce a measurement bias because more people might say Dave Matthews Band than would otherwise say it in a normal setting. And the reason we can say is that we're using a leading question. So my question is leading the person responding to say Dave Matthews Band. That's the idea. The next example, suppose St. Johns County commissioners want to know if county residents support changing rules for the heights of high-rise buildings on the beach. So think about who they're interested in finding out information about. They're trying to find out information about people's opinion or county residents' opinion of changing the rules for high-rise buildings on the beach. So what do? They send out a survey only to beach residents. So why would this be problematic? Well, this is a sampling bias, clearly. If we want to know the opinion of everybody in St. Johns County, but we only ask people who live at the beach, we're not covering all of St. Johns County. So we're going to say this is a sampling bias. And we'll just say only included beach residents, or one portion of the county. And so as you listen to the news and see stuff online about the election in the next few weeks, think about questions that people have asked in these polls and if any of this stuff might apply. Let's try this one. Suppose you want to estimate the mean GPA of all students at your school. So to do this, you set up a table in the library asking for volunteers to tell you their GPAs. Do you think you would get a representative sample? Why or why not? And hopefully you see that this is not a good way to conduct a survey, right? I would say no, definitely not. And the reason is a couple of different reasons. It's voluntary to respond. So voluntary response. Who do you think is going to tell you their GPA if you're just asking them to voluntarily report it? Probably people with only higher GPAs, right? If I've got a pretty low GPA, I'm not just going to give you that information, most likely. Even if I have a high GPA, I may not want to share that information. And so this will clearly cause some kind of a measurement bias, and it will probably skew the mean GPA that I compute. I'm guessing it would be higher than the true value would be, and because most people are probably going to give you something higher than that's their real GPA, or they're not going to answer unless they have a high GPA. Let's try this one. A teacher at a community college sent out questionnaires to evaluate how well the administrators were doing their jobs. All teachers received the questionnaires, but only 10% returned them. Most of the returned questionnaires contain negative comments about the administrators. Explain how an administrator could dismiss the negative findings of this report. Well, does this represent the entire population? If only 10% return them, I would say that's a pretty low response rate. So we could jot that down. It's a low response rate. So is this representative? Probably not. So we could say not representative of the population. And so this is going to create a sampling bias. You could also, I think, even say it's going to create a measurement bias. I think an argument could be made that it's measurement as well, because the people who responded were the people who were really passionate about this issue, and they all gave negative comments, or most of them gave negative comments. There's probably people who are happy with the administration, but they didn't bother to fill out the survey. And so that low response is really, really a problem. And if you think about, if you're new to Flagler, what we do at the end of the semester is we send out email reminders to fill out your evaluations for your classes. And we keep sending these reminders out until we get something like a 70 or 75% response rate. And the reason is because we don't want to end up with a 10% response rate. We want something much higher than that. And so this is the reason. We don't want to have a sampling bias or a measurement bias. Okay, let's try the next one. A phone survey asked, listen to this question. The phone survey asked whether Social Security should be continued or abandoned immediately. We only called landlines, which is almost a silly thing to think about these days. We only called landlines. Do you think this would introduce bias? And I hope you see there's a couple of issues here, right? So first of all, landlines, if someone's using a landline, you're probably only asking older people. That's, not to be prejudiced or anything like that, but you're probably only asking people who are older, because that's probably who's responding to a landline phone call, or people who are a little bit older. So I would say we're going to get a sampling bias because only landlines were used, which probably indicates an older sample of people, an older demographic. I would also say there's a measurement bias here because the question is non-neutral. The question said, do you think Social Security should be continued or abandoned immediately? That's a hard thing to argue. Should we abandon it tomorrow? No, I don't think anyone would say we should abandon it tomorrow. So I would say the use of the word immediately is using something that's non-neutral. So it's a non-neutral question again. And again, those are the things you want to think about. When you hear people talk about survey data, what did the questions ask? How were the questions phrased? Who did they talk to? Who responded? Those are the things you want to think about. Last example here. A school district is interested in finding out what percentage of voters in the district favor passage of a school bond measure. The district sends out a survey, so pay attention to who they send the survey out to. They send it out to all school parents, only school parents. And they ask, do you favor the passing of a school bond measure to provide additional resources to improve educational opportunities for your student? What could be some biases here? Well, first of all, we've got a sampling bias. Why do we have a sampling bias? Because only parents were asked the opinion. People that don't have kids in the school system might have a completely different opinion. And so it certainly doesn't represent the population of all voters in the district. And then I would also say you've got a measurement bias for the same reason as the last example, the way the question is worded. The way it's worded says, do you support passing a school bond measure to provide additional resources to improve educational opportunities? And so the answer is that that's a non-neutral question. Once again, non-neutral language. All right. Last example, or last little box here. A simple random sample. Draw subjects at random from the population without replacement. A simple random sample in which every member of the population is equally likely is what you always want to shoot for. So we'll stop there and then we'll do some practice with this in class.